Thank you for joining this lesson, linear motion number 19. So we are told that a car accelerates from rest for 10 seconds until it reaches a velocity of 12 meters per second. It then continues at this velocity for the next 40 seconds, after which brakes are applied and it comes to rest at a constant retardation of 1.5 meters per second squared. Determine part 1, the acceleration over the first 10 seconds. So it should be known that acceleration is usually given by final minus initial divided by time, because acceleration is change in velocity per unit time. So final velocity minus initial out of the time taken. So this car is accelerating within 10 seconds, that is, and it is from rest. So rest is 0 meters per second until the velocity is 12 meters per second. So the final is 12. So 12 from 0 within 10 seconds. So acceleration is going to be 12 out of 10, which is 1.2 meters per second squared. That is the acceleration in the first 10 seconds. Then the question continues to a part B now, which says the time taken during the retardation. So it is going to retard from the 12 meters per second until rest, and the constant retardation is given. So until rest means final is 0, initial is 12 meters per second, and the retardation is known. So retardation, which is 1.5 meters per second squared, should be known that this is a negative acceleration of 1.5 meters per second squared. So we have acceleration itself, we have initial, and we have final. What we want is the time taken for that. So we go again to our formula of acceleration equals to final minus initial divided by time. So acceleration negative 1.5, this is equal to a final velocity of 0 minus an initial velocity of 12 divided by the unknown time. So this will be negative 1.5 times t equals to negative 12. So that to remain with t now, we need to divide 12 and 1.5. So 12 divided by 1.5, this gives us exactly 8. So this should be 8 seconds. Then after this now, we're taught to draw velocity time graph for the journey and use it to determine. So to draw velocity time graph, we need to have velocity on the vertical axis and time on the horizontal axis. So from 0, this is velocity, this is time, because it is velocity time graph. Time is in seconds, this is in meters per second. So from 0, within the first 10 seconds, this vehicle accelerated until 12 meters per second. Therefore, we're going to have that captured. Then now it maintains this velocity according to the instructions. It then continues at this velocity for the next 40 seconds. So this fixed now, or this constant velocity of 12 meters per second for the next 40 seconds. So for next 40 seconds, so from 10, we will be at 50 seconds. Then now after traveling for that fixed velocity, now it decelerates to rest within 80 seconds, within 8 seconds according to the calculation above here. So within 8 seconds, it you get within 8 seconds, so this will be at 58. So that is a rough sketch of the velocity time graph. From 0 within 10 minutes to a velocity of 12, then with that constant velocity of 12 for 40 seconds, then now decelerates uniformly within 8 seconds according to the calculation up there. So we're going to determine using the graph the total distance covered by the car. So it should be known that distance traveled is usually given by area of graph that is in a velocity time graph. So area of the graph is taking a trapezium shape. So we shall have half times the height of this trapezium shape. So the height is 12. Then we multiply by the sum of the two parallel sides in the trapezium. From 10 to 50, this is going to be 40, plus from 0 to 58. So we shall have by 21 by 2, 6 multiplied by 98. So this is going to be 6 by 98. It gives us 588 meters. This will be the distance traveled by this car. And finally, the percentage of the total distance which was covered during the first 15 seconds. So the first 15 seconds, we had 5 seconds here, 15 seconds. So now the first 15 seconds, it will be this distance now. So we can do this distance, and we will have, I'll have to use two shapes now. This is 5, this is 10, then the height is 12. This one is fixed. So I use a triangle and a rectangle at the same time. So I'm going to add half times a base of 10 multiplied by a height of 12, then plus the rectangular shape 5 by 12. So this is giving us 60. But on the other side, we shall have by 21 by 26, again 60. So I'm getting 120 meters as the distance traveled within the first 15 seconds. And the total distance, remember, is 588. So the percentage of this distance now is going to be 100% of the distance traveled is 588. So what about 120 meters? What percentage will it take? So 120 by 100 divided by 588. So 120 by 100 divided by 588. This is going to give us 20.41%. So that is the percentage of the distance traveled in the first 15 seconds.